So I want to say hello and talk a little bit about what it is we're going to talk about today. I am a senior product manager trying to navigate the waters of things security for the Red Hat Enterprise Linux operating system. And because of the way that our operating system works, the security and identity features that we put into RHEL also end up working their way through the rest of the Red Hat portfolio. Fapolicyd is something that if you know anything about security, you know security isn't any one thing, any one product, any one application, and it may not look the same depending on where your systems are and their purpose throughout your environment. A lot of it is policy, a lot of it is mitigating risk and navigating all of that and what you can't, what you have to open up because you might need performance, right? You have to then close off because of policy or disconnecting it or limiting access in other ways. So we're going to deep dive today in Fapolicyd. I am contractually obligated to always tell everyone you should run with SELinux on and enforcing because that is also important too. But we're going to talk about that. We may also spend a little bit of time. Zero trust has been a buzzword in security for way too many years now, but just reviewing that and some things that are important here. So by the end of the day, you should understand where Red Hat is, what they do to help you with all things security, with some deep dive into SELinux and Fapolicyd and how you can run and develop and use these across your environment and why you should. And then just a good harkening back to compliance. So that's kind of the overview of where we're going to go today. Just a show of hands, how many of you are running Linux within your environments? Okay. How many of you are running RHEL? Okay. Any CentOS? Still? You got a couple weeks. How about anything Debian, SUSE, any flavors of Unix, AIX? Okay. All right. Well, it's good to see, and I hope I can convert more of you to RHEL. I love RHEL. But no matter what you're using, have a security policy, have a security plan. So you've heard zero trust, right? Remember, it's been a buzzword. When it first came out, it was incredibly overused, right? But it's not any one product, not any one solution. The architecture and the strategy is what you're trying to do. And it is extension of defense in depth. Security is an onion. You remember all those things. There are all these layers and all these things that you have to do and determine to get them to work together. So I'm going to help with some best practices, a little bit of understanding, and then we'll do the deep dive. Okay? If you have paid attention to CISA, they look at the things that you need to protect and the way that you need to observe them. So when you're looking at zero trust, you're protecting things like your identity, your devices, your networks, your applications and workloads, and your data. Your data is incredibly important to you. It's where your customer's data lives. It's what you can be fined for if it gets exposed out on the internet, right? And these are the things that you want to protect and secure. How do you do that? You have things like visibility and analytics to help you see what's going on with your environment, knowing what's being accessed, who's accessing it, how much. And then when you're deploying your systems, you need for them to be not snowflakes, right? They need to be consistent. You need to know that your systems are meeting a baseline of compliance. And you don't want to do that machine by machine with one person going from one to the next, because he'll never be done, right? How many of you have very lean IT departments that are like 2, 3, 5? Yeah. How many people have all the staffing you want and you've got extra people? Anybody? No, that's not the world that we live in, right? So we want to do this with automation because any good sysadmin will tell you that they do repeated tasks through automation. And if you annoy them enough, they will replace you with a very tiny shell script. If you've known any grumpy sysadmins, that's what they'll tell you. And all of this is abiding by governance laws because that's who's going to fine you if you don't maintain your compliance. When we look at Red Hat, and in particular RHEL, these are all of the capabilities that we provide within the operating system and that gets provided to the portfolio, from cryptography to all of the security features. And when you are choosing an operating system, choose the ones that build security in by default. This is going to give you the tools that you're going to need to choose your security strategy to be able to move forward. So things from SELinux and Fapolicyd, we have some capabilities with confidential computing. We have a lot of identity and access management capabilities as well, working with hardware storage modules for HSM, so you store your secrets outside of the operating system and onto a hardware device. All of these things are good security best practices for you to use when you need them. And there's much, much more. Okay. And you have told me that you have very small IT teams. You don't have a whole lot of time. If you work to deploy by putting security in at the beginning when you deploy it, when you build it, it helps you to make sure that you are not in a state where you can be compromised. It's just hanging out there waiting for you to finish securing it. And it helps you to limit the attack vectors. And of course, you need to meet your compliance requirements. So pick a security baseline. I'm not going to spend a lot of time here. You know what they are. If you are in financial, it's usually PCI DSS. You can have CIS, HIPAA for those that are in the medical field. You need to make sure that you are able to choose that baseline and deploy that. RedHat also is able to help you create images that are pre-hardened. So you can actually go through our image builder tool. And just like you would have a VM template that you deploy across your environment, you can actually have this in an ISO or a VM form to where you can have it pre-hardened to the CIS, DISA-STIG, PCI DSS frameworks. And so when you're installing it, it already has the hardenings put into place, and it saves you time and saves your energy, your engineers some effort. You know RHEL. RHEL's what you should be running. We want it to be everywhere you want us to be, right? And we serve the portfolio and larger ecosystem. I have to put that in for my marketing guys because they want us to sell more RHEL, so buy more RHEL. And RHEL is the foundation of everything else within the Red Hat portfolio. So the features that we put in, SELinux, Fapolicyd, our cryptography, post-quantum crypto is coming and we're working on it. The expectation is that it will start to begin to be available with like RHEL 10. And the automation to help you do all of this, it goes into RHEL, it goes into CoreOS, which is the foundation for OpenShift. And all of our automation tools and all of our container images are built off of the same premise with the same hardening and making it securable by default in mind. So why do we do all this? We believe in layering protections. I told you before, security is an onion. Security not only can be complicated, but is complicated, but it's up to you to navigate it. And remember that you want to use the right layers to meet the needs of your system and its use at the time. So we're going to focus in a little bit more on SELinux first, and then I'll talk about Fapolicyd, because these are some of the areas that have been around a long time. SELinux has been in RHEL forever, for a long time now. Fapolicyd is newer, but it's like a layer in on top of what SELinux is able to do. So how many, question time, how many are running RHEL and running RHEL with SELinux in, well, we'll do it the other way. SELinux being turned off. You know you have machines, SELinux is turned off and not on in your environment, maybe probably because an application isn't working well. Anybody? Okay, how many are running with it turned on and it's a matter of your security policy? And how many of you don't know if you have SELinux turned on or not? Okay. What was that? In permissive mode, that's a good place to start. It's not a good place to leave it. But at least you have audit trail to cover your butt, okay? So SELinux is it's a layer of security that gives fine-grained access control over files, processes, users, and apps by policy. And by default, everything is denied, and you have to open up policy to allow it. When you are developing, if you weren't paying attention to SELinux, and we've seen a lot of the really large databases, we've seen some that they didn't have it in mind, they didn't work with it, and their documentation said to turn it off. One of the things I like about InterSystems and what I'm seeing is that they keep in mind that SELinux is important, and the reason why it's so important is this is your best shot at preventing like escape attacks. So a lot of the container escape attacks like run C escape, shell shock, those were all prevented with SELinux being turned on and enforcing, because what it does is it does a process isolation. If this is not allowed by policy, this user cannot execute this particular thing or doesn't need access to this set of files because it's not allowed by policy, they're not able to escape that and they get denied from opening things that they shouldn't. This is an important layer of protection to help keep things from getting in there, malicious attackers getting in there and being able to navigate through your operating system and kick off executable code that they've inserted. This is what helps them to prevent that. It also keeps them from escalating from whatever they entered as into root. So with that being one of your best defenses against CVEs and process escapes, that's important. The other thing to keep in mind is when we look at a CVE, a lot of the CVEs have been mitigated from critical important with SELinux turned on and in enforcing mode down to low or moderate, because those types of attacks are prevented, right? So it needs to be turned on, it needs to be enforcing. If it's not, you need to start in permissive mode and then start to look to see what would be denied. And if your application isn't something that you can easily fix to help it be better, there is a way to have a targeted permissive mode for that particular application, but still have the operating system running in enforcing mode so that your application can run, and you will need to determine policy additions that you do to help protect it. You're going to have extra layers for that particular application. But then the rest of your operating system runs in enforcing and is able to be protected on that side. So starting in permissive mode is fine. Like I said, it gives you the audit that you need, the trail for you to be able to see what's going on. But if you can, fix the app. And if you can't, put the app in permissive, put the operating system into enforcing. And how should you know when to create SELinux policy? You need to do it the right way. We have a tool called Audit to Allow. And Audit to Allow will create policy for you, but it will open up large doors in your environment because it's just going to make it work for you. That doesn't mean it's good policy. So you need to be able to understand when you should and shouldn't create a special policy. So when should you create a module? You've hit a known bug, or you have some custom installation that you need to allow, right? Those are the times you should. If you look in your SELinux permissive mode logging, when should you not? Or if you've run Audit to Allow, when should you not create a SELinux module? If the files have been mislabeled, if there is a Boolean operating option setting that you can turn on, or if you have many suggested rules that it's telling you to add policy and permission everywhere, it's probably an indicator that there's something more fundamentally wrong, and you shouldn't allow those policies. And if it suggests writing or appending to like default type or user type context, that's way too broad. It's like Windows, all of the domain users, if you're familiar with that, or all of your users. That's a global setting. You don't want to necessarily open that up. Like SELinux, Fapolicyd has the same type of mindset when it comes to applications. So this is something known as application allow listing, and it's combining the authorization with integrity and authenticity for a tighter access control. So SELinux is running on the processes, running within the operating system. Fapolicyd was developed as an additional layer to help confine the applications a little bit better. And when Fapolicyd is combined with things like integrity measurement attestation, or IMA, and running with the kernel attestation capabilities of EVM, this can provide you with tooling that helps you to confine the applications, limit it down to particular users or locations, special attributes that it has to meet. Also along with has the application package been modified, and is it the same software that you installed, or has it been modified by malicious intent? So IMA is a way of signing all of our RPM packages, and Red Hat with RHEL 9 has started to do that, giving you a PKI root of trust back to a certificate, so that you are able to not only have a hash to match up, but you're able to track it back into the secure boot pipeline, so the secure boot certificate, and track that into the RPMs, so that you know that your system hasn't been compromised and it's still the software that you installed is the software that you expect. And Fapolicyd is one part of that. So it's going to give you that fine-grained access control over files, processes, users, and apps by providing allow rules. And by default, everything is denied. Your policy determines what's allowed. It's customizable. One of the things that I've appreciated that InterSystems has done for their products, they are creating rule sets to come with their software. They install in normal locations, and they provide the right kind of permissions into their applications so that things run well. And because it is customizable, there's a way that you need to do this that helps to open up these files so that you can use them correctly. And this just helps to add that extra layer on top of SELinux, but it can prevent execution of tampered applications, or it can ensure that only authorized users can call the application, or that this application can only be run from particular locations in case they put in a compromised module and they're trying to execute it like it's your application. It won't allow it to run because it's not in the correct place. So some best practices for Fapolicyd: understand the framework. You've got the service, you have command line utilities, you've got the RPM plugin, you've got your rule language, and when you create your rules, you can run the FA general script, and it will actually turn it into the rule set that it puts into memory and that it applies against the systems. You manage the configuration in Fapolicyd. You've got the trusted files, so you can say these are the ones I trust, and those that aren't in there are not trusted by default. And then you have your rule set. That's where you have your allow and deny rules stored, and the configuration. The fapolicyd.conf contains the configuration options. When you look at what's here, you've got your language rules, Dieckow rules for updaters, patterns, ELF, all the way down. It reads it from top to bottom, so 10, it'll go through that first, and it ends down at the bottom. You'll see the deny execute rules and allow open rules. It will go from these are the things I need to open, these are the things I specifically need to close, and then I can limit and open up from here. If you are building for your environment, most of your custom rule sets for your applications will go in the 20s range. So the numbers at the beginning help to determine the order of application, and the order can matter, so you want to make sure that it's opening it up correctly and then specifically closing things that shouldn't happen. And then when the rules are compiled, they're put in order by those numbers, and those rules are applied accordingly. That is the bare minimum of what you should be doing with Fapolicyd. But I would also recommend adding in some integrity checks. How do you know if an attacker has gone in and modified your libraries? How do you know? You can look at file size, right? That's fast, but hackers are generally smart. They know how to make their insertion and remove things so the file size stays the same. So while it's fast and it is a method, they can still hide. Another option is creating and generating the SHA-256 hashes. It's better, but just like anything in security, it's gonna slow some things down, right? And by default, we actually don't have integrity checking turned on at all, so it's on you to decide whether you want to do that. And that's why I said it's important to understand what the role of this system is in your environment and make sure that you know which ones need to have it, which ones need the higher performance, or how can I mitigate the risk around it. And the other way to have the integrity checking is by turning on IMA. And IMA is going to use those extended file attributes, working with the kernel EVM and TPM capabilities that can be stored. And it is coded back to a PKI cert, a cryptographic cert, to get that chain of trust. So there are multiple ways to do that, but it is important to determine what is going to fit your needs the best. So when you want to create a rule, they'll be stored in the rules.d folder, stored by those numbers, right? And you will tell it where. I don't know if this has a pointer. I don't think it does. So I will. Can you see my pointer? Okay. So you will tell it what is it going to be allowed to do, where is it supposed to be running from. These are the things I can trust, and you can give it locations. And if you want to be able to put in non-standard directories or non-standard installation, you've got to add it in here. So you could put it in, this is where it normally is. I could add in, and I could trust temp, right? But you're going to have to create custom rules for that. Adding the 256 checksum at least gives it something for it to check before it allows it to execute. And anytime you make a rule, you should check it before you put it into the rule set that applies. But you can always, as root, turn off Fapolicyd to remove the rule and then put it back if something goes wrong. And then you'll tell it to generate the rule and then load it. And of course, I moved it. There we go. And once that's done, you can restart the service. This is what helps you confine. And just like anything else, there are ways to allow things to be very open. You can always combine things down and make it more targeted for your applications. And you can have Fapolicyd not manage certain applications if it's too difficult to figure out what rules you need to make. We also now have automation to help you configure your system so that the rules are set up right, that they're put in the way that you want as well, by using some of the Ansible tooling and the system roles that we have as well. Okay. And you want to be able to maintain that trust. So remember, check integrity, mitigate performance risk, make rules that are specific to the application, the users, and locations, limit the amount of permissions anybody has to be able to do anything. And you're using Fapolicyd as part of your layers of security, but it's going to be used with SELinux and many of the others that I showed before. And we're always, data is your business. It is what you own, it is what you have, it is your customers' trust. So make sure that you're using things to help you protect it. SELinux, Fapolicyd are great, but there are also many other things that you may need to consider and use in conjunction with them to ensure that your systems are running as protected as you can make them. We're doing things in the confidential computing space as well. If you are running AI workloads, this is one of the things that we're looking at that would be a really good application for running those workloads, because it keeps the data that the AI is using and training itself on invisible to the operating system. The operating system doesn't have to see it. It doesn't have to know it. A lot of times when attackers attack, they will just watch. In the operating system layer, they've gotten in through a phishing attack, they've gotten in as a user, and they'll just sit there and they'll start watching what the system does. When confidential computing is put in place, they can't tell what's going on. It's all encrypted, they don't see it. So that's an additional layer to help protect your data. If your data is sitting around within your systems, have it encrypted if it's important data. LUX, data encryption, is important. You can have network-bound disk encryption to help encrypt your volumes and to keep them protected, but to also decrypt them without having to have a user putting in the password. It can leverage the TPM chip to be able to help get that out, or it can also just use the Clevis and Tang pinning architecture to do that. And working with IMA, Fapolicyd, and Keylime, but you want to test things like the system state on boot. And then, of course, all of your data is moving throughout your network. It's running through Cisco routers, right? You want that encrypted, and you want to leverage good, strong encryption. Post-quantum crypto is coming. Q-Day, if according to RSA this year, they're saying it could be as soon as next year or the year after. We'll see. But you want to make sure that you are most of the customers that I deal with, especially in healthcare and the financial services industry, you are not on the latest. You might be on the one right behind the latest, but more than likely you have some key critical applications and infrastructure that are running on really, really old systems. RHEL 5, RHEL 6, there's some RHEL 4, RHEL 7, RHEL 8, right? So making sure that you realize that over the last 20 to 30 years, cryptography has changed quite a bit, right? You may have to make some changes to use stronger crypto, to use better crypto, to make sure that you're using it correctly and you're using it in a way that is taking what is default in the operating system, and you're not trying to hard code in the crypto. Use what's there. And just like I said, you don't want an environment of snowflakes. They're beautiful, but they're incredibly hard to manage. You want to use automation to make them consistent and to make them remediatable so that they can be brought back into compliance once they drift. So all of those things working together. SELinux is important. Fapolicyd is important. If you want deeper dives into SELinux or Fapolicyd, if you reach out to your solutions architects within RedHat, we have some demos and we have some workshops to be able to help you with that. If there's anything else in this talk that you would want a deeper dive on, we also have some demos and labs that can help there as well. And we'd be happy to help you do that. But maintain, build, keep your compliance going. It's not as soon as I get the machine out of the door, it's perfect, it's fixed, that's all it needs. You know, once a user touches a system, it changes, right? And sometimes settings get tripped, or it is now no longer as compliant as I thought it was, but it doesn't matter what I thought it was. What matters is when the auditor comes in, is it as compliant as it's supposed to be when they look at it? So you're going to have to take action to know what's happening and where your changes happen to bring it back into compliance.
So for SELinux and Fapolicyd, they are slightly different in how this works. With Fapolicyd, if you install it, it's enforcing, right? An iris instance will no longer operate because it's not clear listed, right, in the environment. So what we're going to do is we're going to provide the information after Global Summit in our product documentation and on the developer community on how to do this. And there are two elements to it. One is, as she described this, there's one that is like system-wide. So if you do the iris command, for example, like iris start something, you only need to do this once because it works for the entire environment. The locality, that is what she says, right, is always in the same place, right? And that's why that works. An iris instance will always be in a different directory path. So you have to put it there with the right things. But ultimately, the overall amount of thing you have to do is really simple. It's a list of things you need to activate based on the locality that we have, which is like a central locality or the instance. And on the instance, the only thing you need to pay attention to is what is the path, right? So it's very easy to do, but still something you manually need to do because we don't know what is the installation path that customers will take. So there's no automation, unlike our implementation with SELinux.
Yeah. And we've actually added in some automation for Fapolicyd. So it should be something that you should be able to automate. If you know your location, you can set that in as a variable and you can have a system rule run and be able to create that rule correctly for you.
I only learned this morning from her, so I didn't know that this existed yet.
It's very new. It's
very new,
with the last release. But everything, when I look at what I do for RedHat and for RHEL, I am trying to make this easier for you. I know you don't have enough people, you don't have enough resources, and I want security to be consistent. So anything I can do in terms of an automation tool, and goodness knows we bought an automation company for that, right? That's why we have Ansible. We should be leveraging these tools and these skills because it is. I have heard when a sysadmin is trying to harden a particular VM template, it can take them upwards of 6 hours to get through all of their compliance baselines and things like that. Every layer of security you add, it takes time. And doing that machine by machine nobody would want to do that, right? So the more I can give you, the more tools in your toolbox that I can give you that don't require you to have special tribal knowledge, you just need to know what my settings need to be and tell it to go do it, that's the best thing I can do for you to help you scale. Okay. Yes, question?
You mentioned post-quantum.
Yep.
Is that not available in RHEL 8?
So the libraries are currently being brought in, and right now we're expecting them to be available with RHEL 10. There is some discussion right now, depending on what all changes and what all things break as a result, whether we would roll that back into 9. But with where RHEL 8 is in the life cycle and when all this is going to be happening, more than likely it's not going to get put back into 8.
So RHEL 10, when's the drop date for that?
Well, if we look at, we do this 3-year cycle, it should be like 2025 with 10.0. And libraries being available there. When we look at the NIST and NSA's timeline, they're talking like they're starting to see it with 2025, 2026, 2027. It won't be a hard requirement until like 2031 or 2032. So we're working on it. We know stuff is going to break, and if you have applications that you know have hard-coded crypto in it, you will want to look to see what all changes you need to plan for. Mm-hmm. Any other questions? Yes?
Is there any special consideration for containerization?
So containers leverage SELinux and Fapolicyd as well. In some cases, like SELinux, sometimes it's easier to manage and set policy correctly when it is in a container workload. The thing about containers that is very good, especially with the way that OpenShift and RedHat have been doing containers, is you've lowered your attack surface down because you've made the container just what it needs to run the application. And then you are able to apply the rules against that particular application. And when it's in a container, especially running in OpenShift, it cannot get root privilege, or it shouldn't. You need to confine it within a user namespace, and that further narrows the avenue of attack or the amount of things that they can do if they do happen to compromise it. And with containers, if it is no longer compliant, you knock it in the head and grab the last clean and bring it back in, and your data is still there, it's still fine, and your application software is back to the version you expect it to be. So, and as always, encryption, protect your data. There's also confidential containers that are coming as well.
Amy, thank you very much for your time and being here.
Yeah.
You might have seen people going around with the security sticker or pin. We have a few here up front, so if you want to have one, feel free to get one and take one.
Yeah. Thank you. And if you have any other questions or you want to talk about anything security with me, I'm always happy to. So thank you so much.